Okay, class. This is part 3, recorded lecture. I don't know how many parts that we need to record this lecture. Alright, we try. Alright. To cover as much as we can via the recorded lecture. Alright. So, let me explain this coding with layman. Okay. So, this means the code, this is line specifier. Okay. And this is line width is property name. Marker edge color property, this is property name. Marker edge color. Marker face color, this is also property name, and this as well property name. And then after each property name here, it followed with the value. Alright. This is value for this property name, line width. Okay. While for marker edge color, the value is in code, a code of color. Alright. K. So I hope you still remember K for what. I think K is for Cayenne, I think. Alright, let's go back. Am I right? K for Cayenne? Sorry, K for black. Alright, sorry, K for black. Okay, no, this is C for Cayenne. Alright. Sorry. While marker face color here, color can as well be represented by RGB. RGB. This is code for RGB. Yeah. Red, green, blue, I think, or red, green, black. Alright. So there is a value for this. You may search help, but I'm not so sure whether the octave do it have an sufficient help brochures. So, this is online. Yeah. But with MATLAB you can search RGB. Yeah. So color as well you can represent with code. Yeah. I don't have ample time to explore this with you via the recorded lecture, because the constraint time, we do have a constraint time with this recorded lecture. Alright, so please try this. Alright, this is, you can change this number, and then you may see how you change the color. So this is basically RGB code, and this 12 represent the size of the marker size. Alright, so each value must be listed just right after the property name. Okay, well, have a look at this, the line specifier. So this 1 dash mean solid line, mean magenta. The line color is magenta. You can see here the magenta. Okay, dia macam merah kundang kot, I think, bahasa Melayu. Okay, and then this O mean the shape is round shape. And since you didn't mention the color of the face marker, you didn't, and since the coding didn't mention the edge of the marker, so the computer will use a default. So this is a default marker color. This marker color and marker face color and marker edge color is been selected by default. Alright. You may as well plotting the data, set several data. Okay, this is commonly been seen in engineering practice. Okay, we have several lines, because in one graph. This practice is basically to compare the line profile, okay, of the data. Alright, so for this, you need to plot it. The data, you need to list the data pair by pair. So this data X, the pair of it is Y, and then after that we need to plot another second of line. So we need to type X again, because X will plot at Y2, and another one is X again, and it will plot at y3. So basically, the x is the same x, but y is a different response. Alright. Since you will have a different, three different line on the graph, so you need to have a legend. So the legend will represent, will telling, will label at each line for what. So we put it respectively according to the sequence of the coding here. Since you define first, you plot xy, so y here for sin x, so I just simply legend it as sin x. Then the second line is the coding is for sin, the second coding is xy2, where my y2 is. So I type sin x dot with 2.25, okay, time by what is it, sin minus 0.25, okay. And then this is sin x minus 0.5. Alright, so once you write that code, okay, we will write that code on the software that you use, okay. So this is the graph that you will get, okay. And computer, since our code, we didn't put any detailed format of the line, but the computer will use a default, since by this coding it knows that there are three lines on the graph, so the computer will automatically choose a different color for each line. And this is the legend. You need a legend. So when you plot different lines on the same graph, you must have legend, because people won't know, okay. Without the legend, people won't know each line is for what. Yeah, right. Then there is other plot commands, okay, such as fplot. Okay, fplot is essentially a function plot, where you can simply use this function plot, and inside this you don't need to define the x data and y data, but simply you type a function, the mathematical expression, alright, and a limits, okay, the limits for that function. And then can be followed with a line specifier. Alright. Let me check whether we do have a simple example here. Okay, I do have a simple example. Okay, so let me run a simple example here. So CLC. Alright, so I type here, I'm using fplot, and I have a simple mathematical expression here. X power of 2 plus 4, and then times with sign 2 times by x, and then minus 1. Alright, okay, this is my expression, and make sure you enclose this expression with apostrophe. Alright, then comma, and then I put the limit. So the limit is basically, what is the limit? The x lah. The x is my limits. So it starts with -3, and then finish at 3. Then I close the function plot, okay, with a round bracket, and then enter. So this is the graph that you will get. Alright, this is the graph. Okay, simply. So at certain application, you may need to use just fplot, okay, where you don't need to define the data. Okay, whether for a common example when we use a plot is when we have a data, let's say experimental data, so we use a plot. But if you only have a mathematical expression, You just want to check the profile of the mathematical expression, so you just using as plot. Alright. And then in some application, you may hold on or hold off, okay, to plot a several graph in one figure. Alright. But I seldom use this. Alright. But you may explore if you would like to use this for during your assignment. So, so let's try this. Hold on and hold off. How does it work? Sorry for that noise. Okay, my sick noise. X equal to -2, and then 0.01 colon 4, and then square bracket, semicolon, then y equal to 3 times by x, and then dot exponential 3 minus 26 times x plus 6. Okay, this is the mathematical expression where I'm using x in this mathematical expression. Okay, and then I do have another mathematical expression yd assigned to 9 times by x dot exponential 2. Okay, I hope you know why I use dot operator. Okay, then ydd, another mathematical expression, 18 times by x then I type plot. Okay, so I plot xy. Alright, I plot xy, then I use, alright, and close the round bracket. Okay, so now I'm plotting the xy data. It takes time. This is the data plotting behind it, because sorry, again I'm calling the figure again. Where's the figure? It appears at the back of the alright. Okay, this it, and then I use hold on. This hold on. Where is my hold on? Hold on. Alright. Okay, so then I type plot again, x, but this x plotting to yd, and then close round bracket. Alright, look what happened to this graph there. Now you know how hold on work. Alright, plot, and then I plot another data, x, ydd. Alright, then the apostrophe colon. Yeah, my line format is colon, and then K for black. Alright, close one bracket, and then hold off. Right, then I hold off, so that means I complete. There is no data after this. So this is my graph. So this is how hold on and hold off work when they do plotting. At certain application, people like to use hold on and hold off, where they're plotting the graph line by line. Okay, and then there is another example here, another commands for log